So, hello everyone. Today's topic is boats and stream, and it is the continuation part of time, speed, distance. And then we have covered trains, and now we are covering boats and streams. When we talk about boats and streams, downstream and upstream are the two important points that we have to remember, because all the kind of questions will be solved if we understand this kind of these two terms. Because when we talk about river, it has its own speed, right? For example, here when we say downstream, it is along the stream. When, for example, when your boat or you are moving along the stream, along the way, along the direction of your stream, then that would be downstream. Whereas when you're moving against the stream, then that would be upstream. And what would happen when you're moving downstream along the stream? Definitely your speed will get increased, right? And when we are moving against the stream, your speed will get decreased. So we have to consider cumulative speed. We cannot simply consider like whatever, like for example, when we say distance is equals to speed into time, here what we consider speed usually it is simply speed. For example, if man is walking a certain kind of speed, that would be our speed. But in this, specifically in boats and streams, when you're going along the streams, you have to consider the speed of the stream. So here when we say downstream, your downstream speed, that is your cumulative speed, which here we are denoting with d. And similarly for your upstream speed, here we are denoting it with u. And so consider this d and u are speeds only. So this is the downstream. Cumulatively, it would be the addition of your speed of the boat plus the direction speed, your river speed. So that would be added. So when you add the boat of your speed of your boat and the speed of the river, you will get your downstream speed. Whereas vice versa, it would happen in the upstream. Here we have to subtract the boat's speed and the river speed, like based on like what is greater quantity, we will do the subtraction. Definitely it would be in the plus sign only. So that would be our upstream, right? And just make sure your upstream is definitely always greater than downstream, because what happens, your downstream speed would be always higher. It would be always higher than the upstream speed in any kind of cases, because definitely when you're going with the stream, your speed will be higher. When you're going upstream, that is against the stream, your speed will be lower, right? And this basic formula, that is distance is equals to speed into time, is also necessary when you're trying to solve this both and stream question. Therefore, I'm gonna suggest you guys, if you are not watched the time, speed, distance videos, please go watch them first, and then come to the boats and stream, because I consider this boats and stream as a continuation part of time, speed, distance. Now we will go for the first question. So yes, so this is our first question. Here we have been given upstream speed, that is at 7 km per hour, and we have been given downstream speed, that is 10. So your upstream speed is 7, right, and your downstream speed is 10. And here we are not mentioning kilometers per hour. Why? Because our speed we have to find still water, man's rate in still water and rate of current, we will find it in kilometer per hours only, right? So yeah. So as I've already mentioned one formula, it's not a formula, it's just a basic, understanding that when you're going downstream, you have your speed will be increased, right? And if your boat is moving or man is moving, right, it would be man plus your stream speed, that is your river speed. This is nothing but your downstream formula, right? Similarly for upstream, when you're going against your stream, it would be decreased, right? For example, if a man is going in some direction, in the east direction, and the stream is in the west direction, then what happens? M minus R, right? Now we have been given 7 and 10 as D and U, right? 10 as D and 7 as U. If you just simply see these equations we have written here, like if you just simply add this, what would we get? U is equals to M minus R. Simply you can just directly cut this out, right? And then du plus d is equals to 2m, right? So u plus d would be equals to 2m. Now what you want to find out? You want to find out rate of man's rate in still water. Either you will be asked to find the boat's rate, right, or simply the man's rate. That will be the mostly that will be the case. Here simply we just have to find out the man's rate in the still water. which means speed of the man. And this is nothing but 2m, means here this is the man speed only, and this is the downstream speed, this is the upstream speed, this is our man speed, and this is our river speed, that is our stream speed, right? Now u plus d means what? 10 plus 7, which is equals to 2m. 10 plus 7 equals to 2m, and therefore m would be equals to 17 upon 2, which is nothing but 17 upon 2 is nothing but 8.5 kilometer per hour, right? That will be our man speed. Similarly, when we want to find out the river speed, we just have to simply substitute this m in this equation, or in this equation, whichever you want. Simply just for example, if we have been given our downstream as 10, right, and m we have found out as 8.5, and our river is r, and this is the downstream equation, therefore it is plus in between simply. So therefore r would be equals to 10 minus 8.5, which is nothing but 1.5 kilometer per hour. So it is the most simple question of both and stream. I hope you understood it, because if you are not understood, I suggest you go through this question again and try to understand what is downstream, what is upstream, how exactly we have written this, and everything, right? So next question, it will be easier for you guys to understand all those next questions. So this is our second question here. A man takes 3 hours 45 minutes to row a boat 15 km downstream of the river and 2 hours 30 minutes to cover a distance 5 km upstream. We have to find out the speed of river current in kilometer per hour, right? Now, first of all, when this kind of time is given, where 3 hours and 45 minutes, try to convert entire thing into the one unit. But here we will convert, as we require our answer to be in hour, we will convert this time, which is nothing but our downstream time, right? A man is taking 3 hours 45 minutes to row a boat downstream, right? So therefore this is our nothing but downstream time, right, which is nothing but 3 hours 45 minutes, right, which is how can we write this? It is 3 plus 45 by 60. As this 45 is in minutes, we have to simply divide this in 60. For example, if this would have been in seconds, we would have to divide that in 60 into 60, right? As it is in minutes only and we have to convert it to hours, right, we just have to simply divide the 45 by 60, and in between this we have to make sure that we have done plus. So this is 3 plus 3 by 4, 15 3s and 15 4s are, which is nothing but 12 plus 3, that is 15 by 4, and entire thing now is in hours. So 15 by 4 is our downstream time. Similarly, for our upstream time, you can see that 2 hours 30 minutes to cover a distance of 5 km upstream. So what is our upstream time? Similarly, 2 hours plus 30 minutes, 1 by 2. So 2 plus 1 by 2, which is 4 plus 1, that is 5. 2 into 2, 4 plus 1, that is 5 by 2 hours. So this is our downstream, this is our upstream time. Now as we know that we have the formula of distance is equals to speed into time, and we have already been given our distances, right? So 15 km downstream and 5 km upstream, right? 15 km downstream. So length downstream, it is nothing but 15 km, and length upstream, it is 5 km. So from this formula, distance is equal to speed into time, we can get our speed. Here, for example, our downstream speed, this is length. Just consider, just to make sure that we were not confused between the distance and the downstream speed, we will mention our distance as L here. So, and this is our downstream speed. So this is D would be equals to L upon T. Am I right? So this is our downstream speed. Speed is equals to distance upon time, and distance is downstream distance, which is, so this is LD, so which is 15 upon, time is what? 15 upon 4, right? 15 upon 4. So simply 15 will cancel, and 4 km per hour is our downstream speed. Similarly, for upstream speed, U is equals to LU upon T, which is 5 by 2, which is 2. So 2 km per hour it is our upstream speed. Now we want to find out the speed of river current. We already know that downstream speed is equals to, when we add this boat speed or man speed, right, boat speed or man speed plus stream speed, that is our river speed, and upstream would be equals to boat stream or boat speed or man speed minus our river speed, right? If you subtract this equation, and make sure you're subtracting u d minus u, I mean you're subtracting your upstream to downstream. Why? Because downstream is always greater. So if we just subtract this, you will get d minus u is equals to, this is cancelled and this is 2r. Am I right? And now r would be equals to d minus u by 2, which is nothing but 4 minus 2 by 2, which is 2 by 2, that is 1 kilometer per hour. So 1 kilometer per hour is our speed of the current, that is our river current. So this is our third question here. Man can row 18 km per hour in still water. It takes him thrice as long as to row up as to row down, which means man's speed is 18 km per hour, and it is taking him thrice as long as to row up as to row down, right? So as we already know that our downstream speed will be always greater than the upstream speed, right? Similarly, our downstream time would be always lesser than the upstream time, right? Of course, speed is higher means what? Time required would be less. When your distance is constant, your speed is inversely proportional to time. Therefore, as it is already mentioned that ut is equals to 3 times dt. Ut and dt means what? This is upstream time and this is the downstream time. It is taking him thrice as long as to row up, which means upstream time is 3 times more than your downstream time, than his downstream time, right? And we know that distance is equals to speed into time. Therefore, time would be equals to distance upon speed, right? Therefore, L by S means what? Speed. U equals to 3 L upon D. Distance is same, you can just simply cut it out. Why? Because distance is first of all constant in this case. When it is mentioned here that it is taking him thrice as long as to row up as to row down, if it is, even though it is not distinctly mentioned that distance is not equal or equal, we have to make sure that we understand by reading this statement. When it is taking him thrice as long as to row up as to row down, the distance is constant when it is going upwards and when it is going downwards. So simply 1 by u is equals to 3 by d. I hope this is understood. By writing this equation from the given statement, we have derived this particular fact here. So therefore d is equals to 3 times u. And we already know that distance is d is equals to, not d, here d is downstream speed, this particular d is distance. So this is distance, this is downstream speed, right? Now, so this is the downstream speed. D is equals to m plus r and upstream is equals to m minus r, right? Therefore, simply just substitute these values here. Why we are substituting? First of all, understand that we have been already given our man speed. M value is already given as 18 and we have to find out the r value. The stream, right? Because we have to find out the rate of the stream, which is nothing but our r. We have to substitute this particular terms in this equation, which is nothing but m plus r is equals to 3 times m minus r, that is m plus r is equals to 3m minus 3r, which is, if you just take this particular 3r to this side, so r plus 3r is equals to 3m minus m. Therefore 4r would be equals to 2m, which means 2r is equals to m, and we have already been given m value as 18. So 2r is equals to 18, therefore r would be 9. So r is nothing but your stream rate, that is rate of the stream, which is nothing but 9 km per hour. So this is our fourth question. Here there is a road beside a river and two friends started from place A and then moved to a temple situated at place B. and then returned back to place A again. Now one of them moves on a cycle at a speed of 12 km per hour, while other one sails on a boat at the speed of 10 km per hour. Now if a river flows at the speed of 4 km per hour, which of the two friends return to the place A first? Right. So one friend, he is going from cycle and one friend is going from the boat. That is the main question. Like for example, so here we have a place A, we have a place B, right? Both of the friends, they are going from place A to place B and then coming back from place B to place A. One friend, he is going from cycle, and second one, he is going from boat, right? Now when we say cycle, we just simply have to consider one fact, that is distance is equals to speed into time, right? So initially when he was going from cycle, the speed was 12 km per hour. So for the first guy, the speed is 12 km per hour. So it must be his speed for going from A to B as well as coming back from B to A, right? But like when we go for boat, when we go with boat, we have to consider the factors like upstream and downstream, right? Now here, the second person, when others sails on a boat at speed of 10 km per hour, consider from A to B, it is downstream. From A to B, it is downstream. And from B to A, it is upstream. You can consider vice versa too, right? Just here I have considered first A to B is downstream and second from B to A as upstream, right? Now when a person B means second person, when he is going from A to B, his speed, the boat, his speed is D. Am I right? And what is D? It is addition of boat speed, the boat on which a person is there, plus our stream speed, and stream speed is given as 4 km per hour, and boat stream is what? 10. So 10 plus 4, this is nothing but our downstream speed, that is 14 km per hour, right? Okay, so here, so boat at speed of 10 km per hour, this is a boat speed and this is the stream speed. Stream is river speed, so B speed is 10 and 4 is river speed, right? So this would be our downstream speed. Similarly for upstream, it would be 10 minus 4, which is nothing but 6 km per hour. Now from going from A to B, if we consider it as downstream, he's going at 14 km per hour. Coming back from B to A, he's taking 6 km per hour, right? Then what would be the average speed? What would be the average speed? It would be average speed is a formula. What is the formula of average speed? Total distance upon total time. So this is your average speed formula. What is your total distance? 2D. Like for example, if we consider this as D, this is D, so it would be 2D, right? And then again going back from and then for what is time? Time formula is distance is equals to speed into time. Therefore time would be distance upon speed. So for the first time, that is from A to B, distance is D and speed, what is the speed? So for A to B, speed is nothing but 14. Similarly for coming back, it is 6. Here we are calculating average speed, right? We cannot singularly go for the downstream and upstream speed, as we have to go for both of the directions, from A to B as well as from B to A, because we have to find out which of the friends return return to the place A first. And we know that the average speed for person A is 12 km per hour, because simply it is already mentioned from A to B as well as from B to A, it is 12. We are finding the average speed for the second person, that is for both person. So this is DD cancelled here, right? So 6 plus 14 into here 14 into 16, right? Taking the LCM of this 14 into 16 and cross multiplying this 6 here, 14 here, and then taking the LCM, that is 14 into 6 in the numerator. So this is nothing but 42 upon 5 km per hour, that is 8.4 km per hour. So this is his average speed, whereas average speed of person for first person is 12 km per hour. Therefore, as he is faster, first person, that is the person who is going from cycle, will reach to the place A first. So this is our fifth question here. A man can row 7 into 1 by 2 km per hour, that is 15 by 2 km per hour, in still water. And if in a river running at 1.5 km per hour, it takes him 50 minutes to row to a place and back. Right? So going to the place and coming back. So how far off is the place? So we have to find out the distance. Right? So first of all, as man can row 14 plus 1, that is 15 by 2. So this is a man speed. This is nothing but man speed, which is 15 by 2 km per hour. Right? And then this river running at 1.5 km per hour means what? This is a river speed. So this is a river speed, 1.5 km per hour. Now coming, going to certain place and coming back means what? It has covered both downstream and upstream. So what is downstream? It is m plus r, right? And similarly, what is upstream? It is m minus r. Therefore, it would be 7.5. So what is 15 by 2? It is nothing but 7.5. 7.5 plus 1.5, and this is 7.5 minus 1.5. So this is nothing but 9 km per hour, and this is nothing but 6 km per hour. Now, as we already know, going to certain place and coming back means was d plus u. Time required for dt, that is, and then here ut, right? So this is the time, this is the amount of time that is required for going to certain place and coming back from certain place, which is given as what? Which is given, it takes him 50 minutes to row to a place and come back. 50 minutes, right? This is nothing but 50 minutes, and converting minutes to hour, it is what? It is 50 by 60. I have already mentioned that is when you want to convert from minutes to hour, we just have to simply divide the minutes with 60. So now this is nothing but hour. Now, so this is dt plus ut, right? Time, as it is nothing but time, so this is nothing but dt plus ut. Now what is the formula? Distance is distance is equals to speed into time, right? Then what is the time? It is nothing but distance upon speed. Now you can see that when we go for one place to from place A to B and B to A, here the distance in both of the scenarios is exactly same. So our distance is constant, right? So here, as you can see, from A to B and from B to A, the distance is exactly same. Therefore, in dt also and ut, we have to write distance as d only. Just consider the distance of this as d. Therefore, d by d. Here, this capital D is downstream speed and this small d is distance. And then here, small d upon what is? It is yes. So it is a upstream speed. So it is 50 upon 60, right? So as we already have d, so this is small d upon 9 plus small d upon 6, which is equals to 5 by 6, right? So it is 6d plus 9d upon 54, which is equals to 5 by 6, right? Simply just 6 here and 9 here, and then LCM, which is 9 6 are 54. Now 9 plus 6 is 15 d. So this is 15d upon 54, which is equals to 5 by 6. 6 9s are, right? And then again 3 5s are and 3 3s are. So d is nothing but 3. What is so 3 kilometers? What? 3 kilometers. So d is 3 kilometers. So this is the distance that is between A to B. Right. So this is our sixth question here. In a stream running at 2 kilometers per hour, a motorboat goes 6 kilometers upstream and back to the starting point in 33 minutes. We have to find out the speed of motorboat in the still water. right? Now, as stream is running at 2 km per hour means what? It is nothing but reverse speed, which is 2 km per hour. And we have to find out the motorboat. We have to find out the speed of motorboat in still water. So speed of motorboat in still water means what? It is simply B is equals to what? Now, as it is already mentioned here that in a stream running at 2 kilometers per hour, a motorboat goes 6 kilometers upstream. So distance given, we have been given a distance that is from A to B. For example, if this is upstream, it is given as 6 kilometers. Definitely, when it comes from B to A, it would be 6 kilometers only, right? It is, so this is downstream and this is upstream. Now, and the total time that is required from going to the point B and coming back to A is 33 minutes, right? So here upstream and then coming back to the starting point in 33 minutes, which means ut plus dt is equals to 33 minutes, converting to 2 hours by 60 hours. Now we know that distance is equals to speed into time, therefore time would be distance upon speed, and distance is given as 6, right? So 6 by upstream plus 6 by downstream speed, speed is equals to 33 upon 60. So as we know that the downstream is equals to m plus r. Here m is what? Man speed. Here b, boat speed, which we want to find out. So 6 by downstream, boat plus river, right? Boat plus river. Similarly here boat minus river, which is equals to 33 upon 60, right? Now as we know that it is given to us that r is nothing but 2 kilometers per hour, right? That is the stream speed is 2 kilometers per hour. So that is therefore 6 by b minus 2 plus 6 by b plus 2 is equals to 33 upon 60, right? So therefore if you see this is the formula of a minus b into a plus b, which is nothing but a square minus b square. If you just simply cross multiply this, we will get 6b plus 12 plus 6b minus 12 by b square minus 4, which is equals to 33 upon 60, right? Now if you solve this, similar as we can see here, 12 will get cancelled, then we will have 12b by b square minus 4 is equals to 33 upon 60. Here we can see that 3, it is 3 11s are and 3 4s are, therefore 4b upon b square minus 4 is equals to 11 upon 60. If we simply cross multiply this, we will get 11b square minus 240b minus 44, which is equals to 0. By solving this quadratic equation, we will get our b as 22, so which is 22 km per hour. This is nothing but our boat speed. So this is our last question, that is our 7th question. Here a man can row 40 km upstream and 55 km downstream in 13 hours. Also he can row 30 km upstream and 44 km downstream in 10 hours. We have to find out the speed of a man in still water and the speed of the current. So simply, we have been given 2 equations, right? We just have to simply solve them. So in first equation, a man can row 40 km upstream, right, and 55 km downstream. So as we know that in 13 hours. So as we know that upstream time plus downstream time would be equals to what? 13 hours. This is the total time, right? And what is time? That is distance upon speed. What is the distance? Distance is given as 40 km. Distance is given as 40 km, and then our for upstream, and then 55 km it is given for downstream. So 40 upon upstream, that is here this is a u means upstream speed, and 55 that is our downstream, that is 55 is downstream speed, downstream distance. So 55 upon downstream speed, which is equals to 13, right? Now simply in this same manner, from the second sentence, that is he can row 30 km upstream and 44 km downstream, which means 30 km upstream and 44 km downstream, which is equals to 10 hours. So this is our first equation, this is our second equation. When we multiply this first equation with 3 and multiply the second equation with 4, we can we can say that 120 in here we can simply cancel this term out. So just do that. So 120 upon u plus 55 3s are what? It is 165 upon d, 13 3s are 39, right? Now 120 upon u plus 44 4s are 176, right? 176 upon d and 10 4s are 40. If we simply subtract this equation out, you can simply see that this terms will get cancelled, and 176 minus 165 is what? Right here 165 upon d minus 76 upon d is equals to 39 minus 40, right? So 165 minus 176 means what? Minus 11. So minus 11 upon d is equals to minus 1. Therefore downstream speed is equals to 11. It's nothing but 11 km per hour. If we now substitute this 11 km per hour in any kind of in any equations, like for example, if we just substitute in here in the first equation, we will get 40. We will get here 40 upon u plus 55 upon 11, right? 55 upon 11, which is nothing but 5. This is equals to 13. Now 40 upon u is equals to 13 minus 5, which is 8. Therefore u is equals to 5. U is 5 km per hour. Therefore our upstream speed is 5 km per hour and our downstream speed is 11 km per hour. But what is asked in the question? We have to find out the speed of the man in the still water and speed of the current. Therefore we have to find out m and r. This is what we have to find out, and we know that d is equals to m plus r and u is equals to m minus r. If if we just add this term, we can see that this will get cancelled out. So d plus u is equals to 2m, and we know that d plus u means what? 11 plus 5, that is 16. 16 is equals to 2m, so m is equals to 8. So this is our man's speed, which is 8 km per hour. So this is a 8 km per hour is nothing but speed of the man in the still water, right? Now if we substitute this 8 in any of these two equation, as we know that d is given as 11, d is 11 that we have found out. So d is 11 is equals to m is what? M is 8 and plus r. So therefore r is equals to nothing. R is equals to 11 minus 8, which is nothing but 3. So r is 3 km per hour. So that's what we had to find out. Which is speed of the man in the still water and the speed of the current, which is r, and this is the speed of the man in the still water. So I hope you understood all the questions, and these were the most important type of questions when it comes to the boats and stream. And stay tuned for more videos, guys.